isentropic efficiency is given for calculating the final temperature. So we already discussed how the TS diagram is for a air compressor, that is one axial and centrifugal compressor. So to calculate the final temperature, we need the isentropic efficiency and isentropic temperature rise. So using the isentropic equation, we can calculate only the isentropic temperature rise, and by using the equation of isentropic efficiency, which will give the ratio between actual temperature rise and isentropic temperature rise, we can calculate the value of actual temperature rise. That's why they have given the isentropic efficiency as 82%. The thing we had to calculate the work done by the machine and the blade angles. So in this question, for calculating the work done, we can use the equation of temperature, because they have given the inlet temperature and they have given the isentropic efficiency. So I think we have to use the equation for work done in terms of temperature, that is mcp delta t if the mass is given, or either cp delta t will give the temperature rise, that is the T1 minus T2. So T1 is given as 20 degrees Celsius. We have to calculate the value of T2. Okay. For calculating the value of final temperature, that is called T2. First, you will calculate the isentropic temperature by using the equation of isentropic equation and using the pressure equation P2 by P1 is equal to T2 by T1. All raised to gamma minus omega gamma. Okay. And for gamma, we will be assuming gamma is equal to 1.4. It's not given in the question. And Cp is 1.005 joule per kilogram Kelvin, or 1.005 kilojoule per kilogram Kelvin. Okay. The isentropic efficiency is given by the equation isentropic temperature rise divided by actual temperature rise. So we got the equation of T1, and we will find out the equation of T2 dash, then we will get the equation of T2. So T2 dash can be calculated by the equation T2 dash by T1 dash equal to P2 by P1 all raised to gamma minus 1 by gamma. So P2 by P1 is given in the question as 4:1. So we will be substituting the value of 4 raised to gamma is assumed as 1.4. So 1.4 minus 1 divided by 1.4 will give you 1.486. That is the equation for T2 dash by T1. So T2 dash can be calculated, that is T2 dash equal from T1. So T1 dash equal to T1. So which will gives you T2 dash is equal to 435.4 Kelvin. So first we will convert 20 degrees Celsius into Kelvin, then multiply with the 1.486, which gives you the value of T2 dash. If you got the value of T2 dash, we can substitute in this equation. We got the isentropic efficiency 82%, and we got the value of T1, and we already calculated the value of T2 dash. So we will get the value of T2. So we got T1 and T2. We have to calculate the work done. It's mcp delta t, mcp T2 minus T1. So m is not given. We can directly use Cp T2 minus T1, which gives the work done is equal to 174.47 kilojoule per kilogram is the work done for the axial flow compressor. This is the first part we have to calculate. Okay. So we can either use the blade velocity equation or can use the temperature equation for calculating the work done. Okay. Here they haven't given the blade velocity terms, so we will be using the temperature terms for calculating the work done. The second thing we have to calculate the blade angles. For that, again we will be using the equation work done in terms of blade angles. Okay. So work done can be written as blade velocity into Cw2 minus Cw1, and into number of stages. I already mentioned in the beginning. The blade velocity equation work done for only one set of blade. So in the question they have mentioned that this axial flow compressor got 8 stages. So it should be multiplied with the 8 for calculating the total work done. By using the temperature equation, we will be getting the work done for the total work done. So for getting the work done of a single set of blade, we will be multiplying with the or dividing with the 8. Okay. So we'll be getting 174.47 equal to 8 into blade velocity into. We'll be replacing Cw in terms of Cf and tan alpha. So we'll be getting the equation of tan alpha. Alpha 2 minus tan alpha 1 is 1.346. Okay, because blade velocity is given as 180 and flow velocity is given as 890 meters per second. So substituting that value, we'll get the value of alpha 2 minus alpha 1 is tan alpha 2 minus alpha 1 is equal to 1.346. and they have given the reaction is 50 percentage, and for 50% reaction you got alpha 2 is equal to beta 1 and alpha 1 is equal to beta 2. Substitute the values in this equation. Alpha 2 is replaced by beta 1, so tan beta 1 minus tan alpha 1 is equal to 1.346. Okay, and we will be using the next equation. We have already wrote this equation at the beginning. From the first velocity triangle, tan beta 1 is equal to opposite side by adjacent side, that is CRW1 divided by CF1. Tan alpha 1 is equal to CW1 by CF1. So adding these two, so CR1 divided by CF, CW1 divided by CF. So denominator is common, CRW1 plus CW1. CRW1 is equal to, simply we can write CBL. So we can write CBL by CF is equal to tan beta 1 plus tan alpha 1. Okay. So we can write tan beta 1 plus tan alpha 1 is equal to CBL divided by CF, that is equal to CBL and CF is given as blade velocity 180 and a CF 90. So we can write tan alpha 1 plus tan beta 1 is equal to 2. So here is our first equation. Tan beta 1 minus tan alpha 1 is equal to 1.346. Here is our second equation. Tan alpha 1 plus tan beta 1 is equal to 2. Okay. By solving these two, we will get the value of alpha 1 and beta 1 equal to 59.1 degree and 18.1 degree. So we have calculated the two required time, work done and blade angles. Okay. So we will be discussing more question in the coming classes, and thank you.